Let's talk about Marshall and demand function. Marshall and demand function for good x1 is a function of price of good x1, price of good x2, and the income. That means demand of good x1, if we assume two goods, is a function of price of good 1, price of good 2, and level of income. Okay, if we have a utility function u is equal to x1 times x2, if we want to maximize this utility function subject to the budget constraint p1 x1 plus p2 x2 is equal to m, p1 and p2 are the prices of good x1 and x2, so it should be equal to m. How do we solve this? Simply on graph, it means that if we are given this budget constraint, okay, given this budget constraint, we want to maximize our utility. That means we want to reach to the highest possible indifference curve. If this is IC1, this is IC2, obviously highest possible utility will occur where this IC2 is tangent to this budget line if we assume x1 on this side and x2 on this side. Okay, so tangency requires that marginal rate of substitution between these two goods should be equal to the ratio of the prices. At this point, slope of this IC2 is being given by this marginal utility of good 1 upon marginal utility of good 2. It should be equal to the ratio of the prices. That means P1 upon P2 denotes the P1 upon P2 denotes the slope of the budget line, and the slope of this IC is actually MRS. Okay, that means marginal utility of good 1 upon marginal utility of good 2. So MRS is equal to P1 upon P2. MRS is simply equal to marginal utility of good x1 upon marginal utility of good x2. It should be equal to the ratio of the prices. mu1 means simply the partial derivative of the given utility function with respect to good x1 divided by mu2 means the partial derivative of the given utility function with respect to good x2. It should be equal to ratio of the prices. That means price of good 1 upon price of good 2. Okay, when we take partial of this utility function with respect to good x1, derivative of x1 is 1, so we are left with x2, that is here, upon, and symmetrically when we take the partial of this utility function with respect to x2, derivative of x2 is 1, so we are left with x1. It should be equal to p1 upon p2. Solving for x2, we will get x2 will be equal to p1 upon p2 into x1. Okay, now after that we plug the value of x2 is equal to this stuff back into the budget constraint. So we have p1 times x1, p1 times x1 plus p2. In place of x2 we have this stuff. Okay, so p1 upon p2 times x1 is equal to m. So p2 and p2 gets cancelled, so we have same two terms, p1 x1, p1 x1. Since they are the like terms, we can add them up. That means twice p1 x1 is equal to m, and we get the demand function, what we call the Marshall and demand function for good x1 is equal to m upon 2p1. That means demand for good 1 is a function of income and price. Okay, and in the same fashion we can calculate the demand function for good x2. Okay, so since we got this, let us write it as x superscript m, which denotes the Marshall and demand function for good x1. To find the Marshall and demand function for good x2, simply plug x1 is equal to this stuff back into this function. So x2 demand function for good x2 will be equal to p1 upon p2 times, in place of x1 we got this stuff m upon twice p1. Again you can see p1 and p1 will get cancelled, which implies x2 is equal to m upon 2p2. Okay, so these are the Marshall and demand functions for good x1 and good x2. Okay, so in case of Marshall and demand function, we are being given some sort of budget constraint, and with the given budget constraint we want to reach to the highest possible indifference curve. That is, we want to maximize utility. Okay, so maximizing the utility means in this case we want our indifference curve and budget line to be tangent. Okay, here we will have an interior solution. At times when we have a linear function, then obviously we have three options. Since we have a x1 times x2, this is not a linear function, we got here interior solution. I hope I make myself clear here. Thank you.